Hey everyone, this is Bill MacDonald, the Common Sense Math Doctor. And sometimes when you want to teach something difficult, you have to use an analogy or an allegory or a simile slash metaphor to something simple, and so that the students can make that connection. So behind me in my virtual background is an office, and offices are designed to have employees that make the company money. Well, at the end of each month or each quarter, a company checks its net profit, its net income versus its gross income. If there's a loss, it means the company's in the negative. And a term that they often use is the company's in the red. They're overdrawn. They have insufficient funds that month. So what we're going to use today to teach the concept of positive and negative integers in relationship to a problem is a deck of cards, because we have two suits, and I'm not wearing a suit right now because I would have to have my coat to have a complete suit. But there are two suits that are positive. We're going to call positive. The two suits that are positive are the clubs and the spades. We're in the black. The two the two suits that are negative are the hearts and the diamonds, because the saying says we're in the red. And so one way to help kids understand concepts involving integers is to use a deck of cards, because of the two colors that are black positive and red negative. And then we also have zero, which I'll talk about in this video. The problem we're going to go over today is a sixth grade question. And this is a special request by a teacher asking about how I would approach integers. And so this is the way that I introduce whole numbers. And you can even do fractions and mixed numbers with cards, but I'm going to save that explanation for a different video on a different day. So let's take a look at the question and find out what was it that made this question so hard, where only 34% of the students in Texas got it correct. In other words, 1 out of every 3, because 33% is 33.3% is 1/3 of the students. So 2 out of every 3 students did not understand the relationship between positive and negative integers when you're using the 4 operations. So first I'll show you the problem. Then I'm gonna show you 4 little rules that I came up with that will help students remember which rules you have to follow when doing the operations based on positive and negative numbers. So here we go. Thanks again to my friend who purchased a brand new document camera for me. So red, as a reminder, is when you're in the negative in a business. Black is when you end the month in a positive. This was reading readiness. It's category not supporting, which readiness means that 6th graders might have possibly learned that for the first time, which would make it a supporting standard for 7th grade. But I think that we can introduce this to the grade before and grade after, because sometimes once the test is over, we want to be able to begin to prepare the students for the next grade level. So the question says, which equation, the root word comes from the word equal, two things that happen in this case. that are equal to another thing, a sum, a product, a difference slash sum, a quotient. So as you can see, I already wrote the rule numbers, and the question said, which equation is not true? So perhaps one of the reasons that the students chose A and B is because if you take out the one word not, which equation is true, that would mean you would have one true and three falses. So what I suggest you do right away when you have the nots is write the letter T for true 3 times and the letter F 1 time and circle it to remind you and your students you're looking for the statement, the equation, the equality that is not true. Okay, so let me show you my rules. I've made a little chart, and what you might do is take a picture of each portion so that you can do something similar or your own version. You can tweak everything that somebody else, there's nothing new under the sun. Everything is either borrowed, begged, or stolen. Integers, operation, and sign guide. All right. So reminder, red numbers are negative integers, black numbers positive. Subtraction. If we're going to do the operation called subtraction, you subtract difference. I'm going to call that rule number 1. So when you have a red, a negative number, and a black, a positive number, red, black, move back. You can subtract. And if kids make a mistake with this, the mistake is going to be that they put the wrong sign in front. They will subtract, but if the larger number is negative between the red and the black number, you have to make sure that the sign is negative. If the larger number is positive, you may have to make sure that the sign is positive. So a sub rule here is to place the higher number on the top for the operation, use its sign as part of your answer when you subtract. Rule number 2 is addition. Same sign, be glad. You can just add. In other words, if you have a negative integer and another negative integer, you'll be adding up those two numbers and it'll still be a negative result, but you'll be adding them up. If you have two positive integers, and I switch to black just to remind, if you have two positive integers, same sign, be glad, you can just add. And so keeping in mind that a -3 and a -4, when you put those together, that's going to be a -7. You can add them up, but just make sure you keep the sign the same as it looks in its original form when the signs are the same. Okay, rule number 3. Multiplication, division, product, and quotient. All right. When one is red and one is black, red, black, X, except Jack. Okay, in other words, except the Joker. So let me fix that right now so that you can remember. Red, black, except the Joker. Okay. The sign to give is negative. All right. So there's a red and a black Joker, one of each, inside your deck of cards. And so remember that red, black, except the Joker, the sign to give is negative. So if you take a negative number times a positive number, you are going to get a negative sign. All right. If you take a negative number times a positive number times a negative number, it's going to be a negative sign. You'll get the product, but you just make sure that you use a negative sign when one of the two signs, when you do the times, multiply, product, when one of those is negative, the sign has to be negative. Okay, except for the joker as a reminder. Okay, black, black, positives, two positives when you're multiplying or dividing. Red, red, positive. Same sign both times. Answer is positive. All right. Now, a couple of things that confuse kids. When you take a 0 and you divide it by x, by anything, 0, this nothing in my hand, if I divide it into blah, 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 blah parts, the answer is going to always be 0. If I take 0 and multiply it times anything, it's always going to be 0. The problem is when we take something and try to divide it into 0 parts. I can't take something and divide it by 0 and get an answer, because if you do the inverse operation, if we say 0 times something, it's going to equal whatever that something. No, 0 times anything, we just found it right here, but it's always going to be 0. So you can never take a value, positive or negative, and divide it by 0 and get a result unless that is a 0. The only thing that you can do that works is 0 divided by 0. And the only other one that works is you take anything and I'd say blah, 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 blah times 0. The product is always going to be 0. So there's rule 4, rule 3, rule 2, and rule 1. So let's take a look at letter A. I see that it says negative 4 plus negative 3. Okay. Let's look at rule 2 and see what it says. Same sign. I have a negative and I want to add it to a negative. Rule 2, same sign, be glad. You can just add. So I'm just going to take that 4, that negative 4, and I'm going to add, using my joker because positive, it to a negative 3. Sure that I put that negative on the right side. You are going to get a sum of negative 7. That's rule number 1. So since that is true, we would eliminate letter A because the rule is not broken and we only want the one that is not true. Letter B, negative 8, show you, negative 8, there's my 8, times, because it's right up against the parentheses, times, so I have a times symbol here, a positive 2, I have rule 3. Let's read rule 3. Multiplication division when one is red and one is black. go ahead and multiply them, but the sign to give is negative. So 8 times 2, the joker can be 0. Sometimes the joker is going to be solving for x when I teach you how to use cards to teach algebra. Sometimes the joker will be 0. And sometimes the joker in this case is going to be which operation are we going to do? We're going to multiply 8 negative times 2 positive. The answer is 16, but because we have one positive, one negative, that's rule number 3. We got negative 16. That is true. So we're going to eliminate because they asked us which one is not true. Number C, as you can see, quite a few students put that as an answer, almost 40%. So apparently, even though it says subtraction, what you can do is look at the signs first. When you have a subtraction sign and a subtraction sign inside, let's use rule number 2 to apply this. Same sign, be glad you can just add, because 2 negatives cancel out and make a positive. So positive 3, there it is, plus, get my plus joker out, plus a positive 2 because of the cancellation effect. We are going to add those because 2 negatives of the same sign, we can just go ahead and add. So 3 plus 2 is going to be equal to 5. And so what happened was some of the kids went ahead and said, oh, 3 minus 2. So they say in reading and writing that you can't have a double negative. What happens when you have a double negative? It means that the opposite of what you're trying to say is true. I can't not do it, which means I can do it. If I can't not, that's a double negative. And so a double negative is a positive. So in the same way that you would do the opposite in grammar and writing, you would do the opposite in math. You'd say, oh, the double negatives are positive. So 3 plus 2 equals 5. And that is true. So we're going to eliminate letter C, even though so many kids chose it, because we can use rule number 2 regarding addition because of the double negative rule. All right, last one. And it's interesting whenever you bring black and white worksheets into color by using cards, sometimes the kids think they're playing a game and they enjoy it. So you're probably thinking, how in the world is going to come up with a 12? Okay, well, if 10 is 10, I'm going to call it Jack an 11, a queen a 12, and a king a 13. And up to 4th grade, 5th grade, you're supposed to know your multiplications up to your 12s and hopefully your 13s. So we're going to have a red queen, which is a negative 12, and we are going to divide it by a negative 3. Okay, so what rule are we supposed to follow here? We have division with 2 negative rules. Rule number 4 with division. Let me see what it says. we have two negatives. We have, it's either a black, 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 or a red, red. Same sign both times. Answer is positive. So what it means is you can divide the two numbers by each other. The dividend in this case would be the 12, the numerator, and the divisor would be the 3, the denominator. 12 divided by 3 is 4, and we have to determine, oh, we're dividing and both signs are the same, negatives. So same sign both times, answer is positive. So the answer would be a positive 4. And let's see what came out on the choice. It says negative 4. So that's where a lot of kids went wrong. And so what you could have done, if you teach kids the concept of inverse operations, I see over here, whatever you do on the left side with two numbers, divide, you do the opposite on the other side, multiply. So if I say I have a negative 4 times a negative 3, that's multiplication. And those are both negative numbers. Okay. And I'm multiplying with negative numbers. So that's still rule number 4. Same sign both times. A negative number multiplied by a negative number equals a positive product. So since we took this negative number and multiplied it times a negative number, it should have been a positive 12. So when I double checked it working backwards, it broke rule 4 both times. So that's one way that I would teach. And so of course the answer would be a positive 4, not a negative 4. So since positive 4 is not the same as negative 4 on a number line, we would eliminate A, B, and C and D, A, B, C, and we would select D. And one little reminder that I've told many of you, whether you're working in your book or you're working on your computer, it's probably a good idea to annotate on your computer the letter D next to the 25, or to write on your test booklet the D next to the 25, so that the whatever letter it happens to be, whether they change even numbers to all A, B, C, D, or if they leave them F, G, H, I, if they keep practicing this skill, that whatever the letter is, I'm going to put it next to the number so that the 25 in the book will match the 25 in my Scantron or in my computer submission. So that's my strategy for using a deck of cards to talk about being in the black. And so we can do what I call TMIs, teachable moments of instruction, to talk about when a company's in the black, when they're in the red, when they're overdrawn, overdrafted, when the company is bankrupt. All of those terms should be mentioned in terms of vocabulary when you're talking about integers that are positive and negative, because we're always getting and losing money in a company. So they'll always be adding to the bank account and subtracting from it. We'll be making deposits and withdrawals. Think of as many terms as you can to help your students understand. If you, for example, overdraft, you make a debit card purchase and your bank allows you to do that, your balance is going to be a negative integer whole number, and then they will charge you a service fee of anywhere between $25 to $35, depending how mean your bank is. So that's my strategy. That's one way. I think as teachers, you probably need to have a point system where your kids can have positive numbers for really great things. And when things are going wrong in the classroom, such as breaking certain rules, you don't stop at zero. You can get into the negative, and that way your kids can keep track. So if you, for example, have a poker token system, and your students have to give up tokens every time they break one of your rules, well, some kids are going to have a balance of zero, but keep breaking rules. And so you're going to have to keep a bank account, a record on some book somewhere of the negative balance, the how much the student is in the red, the negative integers. So thank you guys very much. If you have students who struggle with positive and negative integers versus what to do with the four operations when they have them, go ahead and share or tag one of your fifth, sixth, or seventh grade math teacher friends. Goodbye, God bless, and good luck.